done this when we would take two lines and find the ordered pair where they intersect. It was the solution to a system of equations. We actually even did this with 3 lines. And then we went and did it with matrices. And you guys got really mad at me because it became easier.
Yes.
Yes. Well, unfortunately, matrices don't work for conics. But what we're going to do here is we're going to take conic sections, circles, figure out where a circle intersects a hyperbola. Figure out where a circle, a hyperbola, and an ellipse could all intersect. We could figure out where just a circle and a parabola could intersect.
How is this easier than what we did yesterday?
Because you will find out that it is very, very easy. This is pretty cool. Look at that. Look at how awesome that is.
How do you do everything? Reminds me of making.
So what we're going to be able, it does, it looks like this,
Yeah.
what is that?
Planet
The
Pizza?
alien guy, Zerg. It's Zerg. So we could actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There could be 12 possible sets of ordered pairs where these things could intersect. It is exciting. Let me show you what this looks like. Let's start with this. We'll start with something simple. We're going to find the intersection of these two graphs. But I'm not going to graph them because that's a pain in the butt. Graphing is a waste of time when it comes to solving systems. If you guys remember way back when in your Algebra 1 classes, you learned how to graph lines, and then you would find the intersection of two graphs. It was very rudimentary, and it was very difficult sometimes to find the ordered pairs. You eventually figured out that solving it algebraically, linear combinations, that kind of substitutions, things like that, wound up being a lot easier to work with. It's the same deal here. There's really no point for us to graph all of these to try to find out the specific ordered pairs. It takes way too long. So what we're going to do is use just linear combination and substitutions to find the ordered pairs. So right now, I have x squared plus y squared equals 13, and y equals x plus 1. Yeah. Well, what is x squared plus y squared equals 13? What shape is that? It's a circle. Very good. It's a circle. And then obviously this is just a line. So what I'm going to do here, since I already have a y by itself, I'm just going to use substitution. I get x squared plus x plus 1 quantity squared equals 13. What do you think you have to do? FOIL. Junk squared equals?
Junk squared.
Junk times junk. Palmer, stop playing your video game. Okay? Which means you're going to have to do some
Oh, wait a minute.
factoring. Yes, sir.
That does drop for about 30 seconds. What
I
is
just
that?
substitute. I just substituted in where I saw.
One is y squared and one is.
Stop dozing off for 30 seconds.
Yeah, 30 seconds.
Move the 13 over to the left, combine like terms. We get 2x squared plus 2x minus 12 is 0. And I just have to factor. So, what is the first rule of factoring?
Take out. At least your greatest common factor.
All right, so factor out of 2. When I'm trying to solve for zeros, if I factor out of 2, does that have any realm of anything else to do with it, the problem anymore?
No.
Nope, it has nothing to do with it. You can divide out the 2 or just leave it, it's not a big deal. So now ask yourself, what times what is negative 6 that you add together to get positive 1? Therefore, your 2 zeros for this possible solution would be? Okay. Here is my suggestion. A lot of these problems are going to have multiple possible solutions. In this case, one of my possible solutions is -3, the other one is 2. Those are just for the x coordinates. We still have to solve for the y coordinates in the ordered pairs. What I'm going to do then is off to the side is put in -3, comma, and 2, comma, knowing that I'm going to have to find the matching y coordinate for those still. And how I find that is I just substitute back into one of the equations. Y equals -3 plus 1, -2. What we're doing here is taking y equals -3 plus 1, and I get -2. So here it's -2. And I say that y equals 2 plus 1, so it is at 3. Again, substitution. This is really all it is. There's a little bit of factoring involved in this, but there shouldn't be any completing the square or any of those types of things. I'm going to do my best to make sure that I give you guys there are some, not gonna lie, there are going to be some of these types of problems where you just can get awful quadratic roots that you have to list through and resubstitute in with 4 plus or minus the square root, or 2 root 13 all over 6 or something just awful. I'm going to do my best to make sure I don't give you that style of a problem. I'm going to try and give you guys, at worst, fractions with halvesies or quarters. Okay? Everything else should be nice and clean. Not so scary, is it? A lot less work than what we were doing the past few days, though, right?
Is that all you do?
Yeah.
You don't have to figure out which one is and then
No.
both are right?
Those were the line. That's basically what we just found out here is where the circle, where the line intersects the circle, we found the 2 points that it intersects. That's it.
Oh, that makes sense.
Yeah, there's squares. I mean squares, but like squared terms. All right. Let's try another one. Oops. Again, you guys know multiple ways of solving systems of equations, whether it's substitution, linear combinations, things of that nature. It's kind of up to you at this point to figure out which one's going to be the easiest to work with. Think about all the different ways that you solve systems of equations when it's just lines. You try to eliminate things. If you had alternating signs, you try to add. If you had same signs, you would subtract. When I look at this problem, notice how you have alternating signs with the y-squared terms? If I do some sort of a linear combination, or just a combination of conic combination, I should probably call it, I'd have to do something to that secondary equation. What would I have to do? Multiply 2. Perfect. So you guys remember how to do this. What's that? Oh yeah,
Wait,
you'll
why
see.
do you need to do that?
What I'm doing here is I'm going to use what's called elimination to get rid of the y-squared term. So I'm just going to write x squared plus 4y squared minus 4 is 0. I'm going to multiply this whole bottom equation by 2. I get negative 4y squared plus 4 plus 2x equals 0. And what I did there is just put things underneath each other. Are we okay with that? Now, when I combine those two equations, what eliminates? The 4y squared and the 4. So you wind up with, when you add these together, you get x squared plus 2x equals 0. Very good. So my two possible solutions here, when you factor that out, you get x and you have an x plus 2. You have a 0 or a negative 2. Those are your two possible solutions for x, which means I already know that I'm going to have two ordered pairs. One of them with x equals 0, the other one with x equals negative 2.
Why is it 0 or negative
When you set those two equal to 0, it's going to be x equals 0 or x plus 2 equals
2?
0.
So you need both.
Yes, sir. And at this point, all you have to do is just go back and substitute in. Does it matter which of the two equations you use to substitute in? Not at all. I'll just use the top one. So when I substitute back in, I have 0 squared plus 4y squared minus 4 is 0. 4y squared is 4. Y squared is 1. So what's y going to be? 4. Negative 1. So y could be plus or minus 1. So if x is 0, y could be 1, or y could be negative 1. So you have to list this one out twice. Okay? You list it out twice. And then I do the same thing with the -2. -2 squared plus 4y squared minus 4 is 0. I get 4 minus 4. Those drop out. And I have 4y squared is 0. What's y going to be? 0. So for this instance, there are 3 possible places that they intersect. 0, 1, 0, -1, -2, and 0.
Is that the top equation that you substituted?
Yes, sir. I can use either one of them. It doesn't matter. It really doesn't. I just choose. I chose the top ones. I just chose the top one. Yes, sir.
So it doesn't matter if it's a circle or anything, you just.
No, I could care less. All I'm doing is figure out where these two shapes intersect. That's it. I'm not graphing it. I don't want to put them in standard form. I'm not going to write any of that out. There's no point. Okay.
Is there really a difference from what we were doing before?
No, you just have a square term. You have these square. You have something to the second power. That's really the only thing that's going to mess you up, because you could wind up with plus or minuses, and that's usually where people forget. Is that if you've got when you take a square root over an equal sign, this happens all the time where people forget it's plus minus. That's all. That's really all there is to this. I figured it's kind of a nice, easy section at the end. I'll give you one more, then I'll let you do some problems. I'll let you guys do this one. Real quick, just make sure. Again, in this case, I'm assuming you guys eliminate, you just added the two of them together right away. Got rid of the y squareds. So you have 2x squared minus 16x plus 30 is 0. Again, factor out the 2. Ooh, excuse me. Guess I. So you have minus 3, minus 5. So you have possible zeros of 3 and 5. Everybody agree on that? Yeah. Okay. List them out. I'll use this one. What I'll do here is say, well, if it's 3 squared minus 9, that equals y squared. So that's 0. So that's easy. If I do the same thing with the 5, I get 5 squared minus the 9 is y squared. So there you get 16 is y squared. So you have plus or minus 4. So you just have to write it out twice. Oh. Oops. Yay! Math that doesn't take an hour and a half to do. Yay! Do those, please.
Can't see them.
I'm standing in your way. You don't have your glasses on. Is that better?
Yep.